back. We have an update from Ideal Power, trades on the NASDAQ under the symbol IPWR, pioneering the development and commercialization of its broadly patented bidirectional semiconductor power switch, creating highly efficient and eco-friendly energy control solutions for electric vehicle charging, renewable energy, energy storage, UPS data center, solid-state circuit breaker, and other industrial and military applications. Happy to welcome President, CEO, and Director Dan Brdar and Tim Burns, the CFO. Nice to see you again, gentlemen.
Nice to be here. Thanks for having us.
All right, give us an update.
Sure. I'll let Tim Burns, our CFO, go through a couple of recent events here, and then we'll take people's questions.
So 2024 is really shaping up to be an exciting year for Ideal Power as we commercialize our B-TRAN technology in SymCool products. We've had two recent commercial announcements. The first was we announced that we'd commenced shipments of our SymCool power modules. So that is a multi-die module really targeting the solid-state circuit breaker space. We expect the industrial markets, including solid-state circuit breakers, to be the first market that really results in the ramping of sales for us here starting later this year. We also had a recent announcement that we successfully completed phase 2 of our development program with Stellantis, a top 10 global automaker. So in that part of the program, we provided them B-TRAN devices, drivers, worked with their packaging team, and also the organization that's actually going to build the prototype inverter for their drivetrain. And the target for that program is production-ready B-TRAN modules in 2025. So right now we're working with them on defining the scope of phase 3 of that agreement that will take that custom module through automotive qualification. As we look forward for other commercial announcements that will be coming here in the future months, one is actually getting the PO for phase 3 of that development agreement with Stellantis. We're also in the process of qualifying a second high-volume production fab. We already have a high-volume production fab that's qualified that's located in Asia, not in China or Taiwan. The second fab is located in Europe, and we're expecting to qualify them here just in the near term. We're also really focused on converting some of the large OEMs that are in our test and evaluation program into design wins or custom development agreements. So we'll be expecting some initial orders for them soon as they evaluate the SymCool technology in particular. We'll also be adding distributors here to really leverage the existing silicon infrastructure that's out there, not just for processing, but also for demand generation, for sales and support. We'll also be having, and this will be later this year, in the second half of this year, initial sales of our SymCool IQ power, intelligent power module, and that will be our second product, and that's really targeting some other industrial markets, things like renewable energy paired with energy storage, EV charging, motor drives, and other industrial applications. And then we'll also begin third-party auto qualification process. So that's a rather lengthy process. We'll be beginning it here later this year under likely phase 3 of that development agreement with Stellantis. And that's something that we'll really be able to leverage for other markets as well. So the auto qualification process is much more stringent. You have to deal with things like shock and vibration than the industrial process. So it will really help us also with the industrial markets, because if we can make it through auto qual with our product, as we expect here to start here later this year, then it will meet all the requirements necessary for any of the industrial applications in our target markets. So again, we're going to have several announcements we're expecting here over the coming months, all related to commercialization of the technology. And it's really setting up for sales to initially start ramping here in the second half of 2024, and then a much more pronounced ramp in 2025. But that's a quick overview. And with that, happy to answer any questions that any of the listeners may have.
Great. That sure was quick. All right, let's jump in. Kim Mendez says EV sales have been slumping. So what other applications are your two directional chips good for? Is it safe to say anything with a battery? Tell us.
Well, anything with a battery for sure. If you think about energy storage put in for industrial facilities or, large utility scale applications, but also for just power control for things like solid state circuit breakers, for circuit protection. It's also really applicable for things like energy storage coupled with solar or wind, and also things like motor drives for industrial applications and UPS systems for data centers where you really want to take advantage of the very low conduction losses that our devices have.
Can you talk about new customers, any large orders? Crystal Adams is wondering.
Yeah, initially the orders will be relatively small as the very large companies we're dealing with will evaluate the technology, start prototyping. which will eventually lead to design wins or custom development agreements. So we expect initial orders to be small, but again, they'll start ramping here as they actually start prototype design, start building initial prototype products. And then obviously in 2025, as we look out there, where we'll actually have some of those design wins going in actual fabrication with these large companies, we expect the ramp to be much more pronounced.
And Jawad asks, can you handle all of these orders that you're expecting? And at what point will you need to ramp up production tools and a facility?
Yeah, part of what we're doing this year as part of qualifying a second high volume wafer fab is to be prepared for the ability to ramp quickly. We've qualified a fab already that is in Asia. They're actually automotive certified. And then the second fab that we're qualifying right now is in Europe. So we'll have plenty of capacity to meet all our needs for the next several years, leveraging that investment that's already been made in silicon processing.
Randy Svedbeck says B-Trans sounds exciting. So how would you describe the level of customer interest versus prior product intros in your career?
For us, it's been really exciting because what we're getting in terms of feedback is opportunities for some of the large industrial companies that we're working with to have a technology that's actually an enabler for them. And the circuit breakers are a great example where some of the very large companies, Fortune Global 500 companies that we're working with, have been waiting for a really low loss semiconductor device to make a solid state circuit breaker. Conventional technology just has not allowed them to do that. And there's a lot of demand that they see in the marketplace because of all the distributed generation that's going in and the need to improve our utility distribution system. So the feedback has just got us excited that people are seeing that we're actually creating opportunities for people to have new products that just weren't there previously.
Yeah, and to add to that, the fact that Stellantis named us the finalist in their Stellantis Venture Awards here back in December has generated a ton of interest. We have actually a second top 10 global automaker in our test and evaluation program. And I would say the level of engagement with that automaker has increased tremendously here over the last couple months. And I'm guessing that's partially driven by the fact that Stellantis was willing to name us as a finalist for one of their awards publicly.
I'm sure. Randy also asks, how important is test and burn to build highly reliable B-TRAN?
Well, for any semiconductor device, reliability is key. We actually are going to go through this third-party test and certification process for automotive. Silicon devices don't have to go through this final burn-in like you see with silicon carbide, but you do have to go through the certification process where you literally go through tens of thousands of power cycles, extremes of temperature, shock and vibration to prove that not only is your semiconductor technology robust, but how it's packaged for electrical connection can also withstand the requirements of the applications. So getting that process started and getting through it, I think, is going to be really key to make sure everybody is comfortable that we've got a really reliable product. The one thing I will say is we spent quite a bit of time looking at the failure mechanisms of conventional power semiconductors like IGBTs, and we designed our packaging. We deliberately made sure that we did not include things like wire bonding and a few other things that are the common failure mechanisms that the industry have seen in other approaches. So we think we've taken a lot of the risk of the reliability out up front, but we'll see how the testing goes just to validate that.
A few questions from David Schneider. David comments he recently read an article about an artificial intelligence data center that was located next to a coal-fired power plant due to power requirements. So how should we think of your possible role in data centers?
Yeah, for us, it's really the uninterruptible power supplies, the UPS systems for data centers. They today use IGBTs. We have extremely low losses on our technology, so very low loss compared to IGBTs. It's probably 50% better than IGBTs in unidirectional applications. It's 75% or greater better in bidirectional applications. So it's something where we can really utilize those B-Trans in the UPS systems. They continuously conduct electricity, and we've done some math just looking at a large commercial data center, and we estimate the annual electricity savings if those UPS systems had B-Trans rather than IGBTs at over $2 million a year. So a significant impact on the overall efficiency and the cost savings for the data center. And
David also asked for an update with the Navy.
Yeah, we actually had a project that we did with the Navy where they wanted to demonstrate a solid-state circuit breaker using B-TRAN as its core. the Navy has come back to us and asked us, are we ready to actually provide commercial devices? And we told them we are. We understand that they're in the process of looking to try and reallocate money where they can actually go to an existing ship as part of this demonstration and retrofit it with batteries and solid-state circuit breakers that would include B-TRAN. It takes a while for them to go through that process. We hope they're successful, but our original project came the same way, where we made a proposal to them, they reallocated money, and that's what got us off and running with the demonstration project with them. So fingers crossed they can figure that out relatively quickly so we can go into an actual retrofit in an existing ship.
And last question from Inez, is there a timeline between phase 2 and 3, and what exactly is entailed in phase 3?
So phase 3 is really taking the custom module that we've designed with a packaging company that they've selected, Stellantis selected, and also an organization they're working on the actual full drivetrain inverter. So that process is something we'll take it through AutoQual, our packaged device. The packaging company will take the full module through automotive qualification as well. In terms of timing, they are a large company, so it tends to be a little slow. We're working on defining the scope with them for phase 3 of the program right now and finalizing the paperwork, but we expect here in the coming months to announce that we've secured phase 3 of that program.
And then the objective of that phase 3 is to have a production-ready module for 2025.
Well, that'll be here before you know it.
Yes,
Thank you so much for this update, gentlemen. We look forward to seeing you again maybe next month or in the near future.
Thanks for having us on.
All right. Stay with us, everyone. We'll be right back with Peninsula Energy.